Yeah, I said we were. I said you needed your Chromebook today.
I don't get my computer.
I have it.
From Hell? Probably should.
Oh, never mind. It was Bubble that you said.
Oh, yeah, we're not doing both.
Bubble.
Okay, so get logged in your nearpod. Your code's on the board, ECVRZ. Get logged back in. Should show you this slide. Again, I'm going to try to use this anytime we do PowerPoints. We're starting chapter 10 today. Now, I know timing-wise, we're not going to get to homework or anything like that. I had an assignment picked out, which is just based on vocab words. That's all it is. It's not difficult by any means. It was like, look at this picture, tell me, what a radius is, what a diameter is. Things you learned back in elementary and junior high days. It was just something simple. We'll just save it for another day. Maybe we'll do it tomorrow or something. So I just know by timing-wise, we're not going to get there because we have too many topics to talk about today. But the whole PowerPoint that we're doing today is introing a lot of vocab words because, even if you think back to chapter 8, chapter 6 test, which we just took, any of the other chapters, the first section is overloaded with vocab terms. There's like every word in the whole chapter is in the first section. You have to learn them all at once. And then the rest of the chapters, they just refine them. They talk about, certain properties about this shape, this shape, this shape. Okay? And that's what we're doing today. We're just going to intro the vocab words, talk about the concepts, what we're talking about, why they're important, why you should know them, and then we'll be ready to go here. It's pretty straightforward. We're just going to do a lot of just intro notes. We're not going very in depth today. But again, log into your code, ECVRZ. Perfect. Okay, the big thing I want you to get today, and the thing I'm going to be checking on the nearpod, is are you getting your notation correct? Like when I have you submit answers, are you using the correct notation for when you submit it? So that's the thing I'm going to look for, so pay attention to that, and I'll kind of give you examples as we go today. So Kevin, code's on the board.
Does it close all the tabs today?
What was that?
Does it close all the tabs today?
No. I made sure I already got that fixed, it won't do that again.
I'm like 5.
Are we good though? Is everyone comfortable with this? Okay.
But what should we not be comfortable with?
That's,
I know.
What?
What should we not be comfortable with? Are we comfortable with this?
are you comfortable?
No,
No.
I'm in school.
Is that a weird question, man?
Yeah.
I won't ask it. Alright.
I don't know how to answer.
Unless you're like teaching us something.
Okay, yeah.
No, it's
Yeah.
not gross 5 minutes.
Okay, let's move on. Alright. Did the next slide click? It didn't.
No.
Here's the deal.
Not yet.
Okay, perfect. Okay. Goals today, as you can tell, let's do a bunch of definitions today. We're going to try to hit the main words, and we're gonna get to some of the new stuff today. One of the formulas we're going to get to today, we'll compare diameter versus radius, and we'll get to circumference. That's probably where we'll end today. There's a couple other ones that I don't think I have on the slide here. We'll talk about area. I don't have it today. We won't get to it. There's things as inscribed and other objects when you put something inside another object or on the outside. We'll talk about that today. But it's pretty straightforward. It's just a lot of vocab words. Do you know what they are? Do you know how to find them? Do you know how to list them? And then I'll show you kind of real life examples why this is like incredibly important today. And hopefully you'll learn a little bit of stuff from it. So, questions before we move on? That's kind of our goal.
And I'm comfortable.
Good. All right, here we go. Definition. Okay, and I have everything on the nearpod, so you don't have to wait for me. Okay. So here's the definition of a circle. It's the locus or set of all points in a plane that is equidistant from any given point. Okay. Now they use the word locus. That's a new word. That's a vocab word for sure, other than the word circle. Locus is any position in space. Now, what they're talking about is that you can pick a bunch of different points, loci, that are all the same distance, equidistant from a central location. So this is the example. I think this showed up in your nearpod, the actual picture itself. But the idea is that these are the set of all the points. There's an infinite number of points here that are equidistant from that central location. Okay? So this could be a locus, or these could be each a locus or a loci. There's plural. but they're all from a central point. Now, one of the words that I put on the slide here that you can see in your nearpod is I define what the word locus is. We've actually seen this word since day one, we just never talked about the word itself. A locus definition is that position, that particular position in space. So like if you think back to August 22nd, the very first day of class, we talked about the word point. Point is just, it's just this position in space labeled with a capital letter. It's a locus. It's just a single dot. It doesn't matter the thickness. It just matters what that dot is and how they label it. So that's a locus. Now, the locus itself that's important on this picture is that central dot. So the central letter here, that's how you actually name a circle. That's just something that a lot of people get wrong. I don't know if it's taught incorrectly in junior high or elementary days.
May I have your attention, please? Jamie from Athletic Code is here. If there are any freshmen or sophomores that need to see her, please go down to the locker room area at this time.
Okay, but how you actually name the circle, and you can see it on your nearpod, you pick the point that's in the middle of the circle, and that's how you name it. I don't know why, but I always get people that come from junior high, and they start listing like all the dots that are on a circle. That's not how you do it. It's just the central dot. That's the name of it. So I think I provided you 2 examples, right? Was it in a little white box?
Yeah.
Just so if you're looking at it, you can actually see it. Oop. There we go. That's weird. Did it just freeze on me? Oh, knock out weird. Deal with it. Yeah, that's why. That makes sense. Okay. Just wonder why that thing just stopped clicking. Okay. That's where I got to. Da-da-da. Okay, there we go. Now it looks right. Okay, this is how I want you to name it. So when you name a circle, you have to call it like the circle C, like the middle dot, or you can draw a mock picture and you put the letter after it. Now I know this seems a little weird, and some people are always like, why? Like, what would be the point of naming it, like other than just picking the points? Because at some point in this middle of this chapter, we're going to get to a point where we have a bunch of circles that overlap each other, like this. And there's going to be a bunch of points on it that are kind of in a straight line. Let's call this A, that's B, and this is C. Where A, B, and C are the centers of their respective circles. And then the other spots where they cross, let's call this like E, D, and F. Those points are just points that are just like intersection points. Edges of the circle, all that good stuff. But this is something we're going to look at. Like the name of this circle right here, that's circle A. Because I don't care that there's an F on it, you have to use the middle letter. That's what's important. So that's what we're going to be looking at, and that's why I want you to kind of look at certain things. And we'll look at other examples later of why that's important. Okay? All right. All right. So what I have here on this next slide for you on the nearpod is I'd like you to take a look at your circle that I have provided for you, which is this one, and I would like you to name it. So think back to that last slide I just told you. How do you name this object? And I want you to write in there, type it with a little text box. I want you to submit it, but I want you to name this circle. So it's just, let's see if you're paying attention to that last slide. I'll even show the last slide up here so you can use it as a reference. So give me the name of this circle and then submit it. You can draw it in there, you can use a little text box. I'll wait on everyone's, I'm going to share it once I see some good ones here.
I can't like. Oh, I need this.
Yeah.
Do you want the directional bearing?
Yeah, you can use the directional bearing or the ones of it.
So I think
Okay.
so if I were to get one of those cameras, that's like it, right?
As long as one of them. Okay, everyone looks like a lot of people are still sitting. It's fine, take your time. I'd rather have you get it read than worry about it. We have plenty of time today. Waiting on what, 3 people on here? Yeah, let's submit, yeah. Okay, so waiting on 2 here.
No clue if that's right. Totally.
I think that's sweet time, I think you guys probably already submitted. You did submit yet?
Yeah, I did.
I think it's sweet time, it says that you haven't submitted yet.
Definitely not.
Kevin, did you hit submit yet?
Yes, sir. Oh, it's loading.
Yeah, that's what mine's doing.
Okay, alright. Alright, here's one that is correct. Now let's talk about it. So I'm going to share it with you, hopefully you can see it on your screen. Yeah, okay, there we go. So, okay, why is it correct? Why is that correct for this picture?
Because it's the answer.
Yeah, but what letter did they choose to use? The middle. Yeah, so that is correct. You write circle Q. Now the reason being, this is one of the examples. This is the notation that you could write. Now a lot of people didn't choose to do that, which is fine.
Oh my god.
I had a lot of people choose to just do something like this, which is fine too. Where they just put the little circle, like the actual like example like drawing of it, and then they put the letter after it. That's fine too. Okay. So that was the majority of what I saw. Those are all correct. I don't think I had anything else. It didn't look like anyone used other letters. I had somebody in the last class, when they submitted this picture, they actually just wrote W, X, Y, Z, Q. And they put like a circle up front. You don't need to use the letters on the outside, just the center. Okay, we good? Moving on, all right. Next words we have to get to. So you're probably seeing in your nearpod, hopefully it's showing up. Eric, if it didn't work out for you, hit like Control R. Let's see if it catches on there. Caught up.
Something isn't right. Still trying, but this may take longer than usual.
You want to like hit Control R. Let's see if it will speed you up.
Little reload button.
Yeah. See if it'll take you to the nearpod. If it doesn't, you might have to like open up a new tab and log back in. Close out the tab around. All right. So on your nearpod, you're seeing all the words we're going to talk about. We're going to talk about first on this particular circle. Some basic words that I want to talk about. So one of the first definitions I want you to know. The segment with endpoints that lie at the center and one is on the circle is called a radius. The radius is the most important line on this circle. It is by far the most important. So you have to start at the center, go to the point on the circle, and it's the segment that connects it. Now this picture actually has 3 different radii. One of them is this. One of the radii is this tick right here, which is called CE. Now there's 2 ways to write it. You can write it like that, where you actually write CE, or you can write CE with bars above it. That's how you write it. That's a radius. Thank you, Whip. Questions on how you write a radius? Can somebody else give me a different one on this picture other than CE? What's another radii? DC. Okay, I like that. You can put a bar above it, or you can just leave it blank.
CF.
CF, okay, I like that. You can put a bar, you can put a blank. Okay, so those are examples of just radii. Radii, what you can do, if you have a radius, you can calculate diameter, you can calculate circumference, area, you can find arc length eventually, something that my pre-calc students do for one of their sections in chapter, I think it was chapter 12 for them. So that's stuff that we will be able to calculate if we have those lengths. Question?
Did you do AC?
No.
Even though that's still
It's got to be drawn. Now, technically, you would be correct if there's a line there that would be radius, but since it's not drawn, we're not allowed to put that in there. Okay, we're not going to fill in our own radii. Okay, questions on what a radius is? Perfect. All right, the next word that's on your nearpod, if you're actually seeing it, I think everything appeared. Yeah, it's already appearing for you. One of them is the segment whose endpoints lie in a circle. This word is called a chord. It's any time you pick two letters that are on the circle itself, and there's a straight segment connecting them, straight across. It doesn't matter where they are. So in this picture, there's actually two chords. There's two chords. The endpoints lie on the circle itself. I'm going to give you one, and I want to see if you can figure out the other one. All right, so first one here. One of the chords is AB. Now you can leave the bars off, it's totally fine. What's the other one? DE. You can leave the bar, you can leave it off. That's a chord. Okay, they go all the way across the circle, and they touch 2 points that are on the circle itself. I don't care that DE went right through point C. You only use the endpoints that are on the circle to name a chord. Does that make sense? You don't use 3 letters. Because again, when you name segments, you don't actually use 3 letters, you only use 2. So I thought that's really good that you caught that. Okay. So again, 2 letters, the 2 letters have to be on the circle itself. Okay. A lot of people don't have an understanding of what chords are. Chords can be any size, if you think about it. There's any type of size for a chord, like AB here is kind of short, right? Because the closer AB get together, then the shorter this chord gets. The longest chord in this circle, like the longest chord you can have, is this one, DE. When it passes right through the center, that is the longest chord of any circle when it passes through its center point. Anyone happen to know the name of a chord that passes right through the center? Diameter. Yeah. Diameter is the longest chord. It passes through the center, and it's made up of 3 what they call collinear points, units. So you have 3 dots that are in a straight line. But when you name a diameter, you still just use 2 letters. So like the example that Brandy you gave earlier, DE, even though that's a chord, it's also the biggest chord, so we could also call it a diameter. Diameters and radii are in relationship to each other. The reason why a radius is related to a diameter is because they're collinear. They're in straight lines. We'll talk about that in the next slide. Okay, so I have the next slide. There's like 3 things I'm going to ask you. So I'm going to give you a bunch of different pictures from the book, and again, just pull these right out of your textbook. I'm going to ask for one of the slides going to ask you for a radius. One of the slides going to ask you for a chord. One of the slides going to ask you for a diameter. So just be kind of ready to go here. Does everyone have the definitions written down now?
It's been like 20 minutes.
Good? All right, here we go. First one, so here's your first picture. I would like you to name a diameter for this picture. Name a diameter correctly, write it in there. You can type it. You can put a bar above it, you don't have to. But I want to see if everyone can submit me a diameter for this picture correctly. Can you name it correctly?
I think this is
Once you have it, click submit. I'll list off the first couple that we'll have here, if they're correct. Brandy, your answer was absolutely massive. Ooh,
Diameter is 3 of them, right?
Bree got fancy. You're drawn. Dude,
I
what?
don't know if it was right.
It's either 2 or 3.
I don't know if I did that right.
Erica's good. Kevin, no.
I did, did you do what I did?
Yeah, I know.
Oh,
Yeah, no.
All right.
it auto-corrected. Jeez, man. What are you doing?
Sure. Okay. Hey, here's a good one. A lot of people have these, so I'm gonna share it with you. There you go. That's the correct way you say a diameter. Now you don't have to do the little like squiggly little squiggle mark on it.
I just thought I'd add a little bit.
Yeah. So you didn't have to do that, but I do like the fact that they wrote it different ways. They used the bar, they didn't. It's one or the other. It didn't matter. That's a diameter. It's only 2 letters. Even though I know it passed through the middle, we didn't need to use the middle letter. It just the 2 endpoints is good enough. Okay. Again, it could have been. You can write it in any order. I didn't see anyone see DB, but.
What did Kevin put?
Deb.
Yeah.
Oh my god.
So not 3 letters. Don't want to do that. So you got rid of the wrong letter, by the way, Kevin.
Why?
You have to use the outside letters. You got to get rid of the E.
What'd I put?
Well, look at yours. It's on your screen.
Wait, what is it supposed to be?
DB.
That's what I put.
You erase the B.
Oh, I put Deb.
Yeah.
That's my grandma's name.
Bed.
All right, here we go. Okay, next one. So next slide you're gonna have here, I think it's a different picture, I believe. Yeah, different picture. This one you have to just name 3 radii. You can list them off to the side, but I want you to name 3 of them. 3 radii. Radii, radius, it's plural. Name 3 of them. Now this picture has 4, but name 3. Once you have them submitted, then I'm going to share.
My thingy is broken.
Yours acting up?
Wait, how many are there?
I drew lines if that works. Do I have to actually?
You have to put the letters. Because the line's already drawn for you.
I hate Q's. It's the dumbest letter in the alphabet.
That's what this is.
Why is there even Q's in the alphabet?
Why is there a G in lasagna? What were you-
Lasagna.
You in lasagna?
There's a G in lasagna.
Lasagna.
You said there's, why is there a Q in the alphabet? And I said, why is there a G in lasagna?
Kevin, stop watching Fortnite.
I am not.
I'm going to have to turn off all the tabs.
Why is there an
I am
O in
not.
awesome?
Can you turn it off for just one person?
I can't.
I'm definitely not.
Do it
doing
together.
that.
Mr. Ward,
Okay.
why is there an O in possum?
No.
In possum.
Possum.
There's an O at the
Okay.
beginning of possum.
Sister.
Oh, possum.
Great, you're drawing it.
I don't know. Why is there a G in rough?
Why is there a B in potato?
All right, here we go. Oh, here's some good ones. People got colorful on these. These are good. Okay. The reason I'm sharing this one, I like the fact that they wrote it differently than I was expecting. They wrote the outside letter then the middle letter. It doesn't matter. That's good. That's fine. A lot of people wouldn't do that. A lot of people would probably submit the Q first, like this. Let me share this one. This one's good. These are all correct, by the way. They put the Q first. That's what I would expect most people to put. Okay.
Something to look at.
Let's see. What are some other ones here? Okay. Here's a good one. They're on some. Actually putting markers down. Putting the QZ, the XQ. Writing it in different ways. Didn't have to put those extra markers in there.
What is that one thing that we learned that last year in science? There's a little snail thing in every shape or whatever.
Oh, the Fibonacci.
Yeah, that's what it looks like.
Okay. So.
And I'm a god at drawing.
Okay. All right. Last drawing here.
Art.
Last drawing here. I'd like you to submit a chord.
Oh.
Submit a chord. Now this picture has 2, but I'd like you to submit a chord. Submit 1, please. I want to see if you can write it correctly. Again, remember, chords are written a certain way, radii are written a certain way, diameters are written a certain way. I want to see if you can list it.
A chord?
Chord,
I forgot what that meant.
chord.
What's the difference between a chord and a
Wait, how many do we put?
Oh.
Just
I
one.
don't know.
I just need a chord.
What are you doing?
So fun.
Mm-hmm.
That's alright,
I spell chord.
CHORD.
Uh-uh. It's not how you spell chord.
The geometric chord.
No. C-O-R-D. Geometric one is K-O-R-D.
Okay, I know.
Kevin, you were fine, right?
All right, we good?
Look at the day.
Everyone's got it submitted? All right, let me show you one. Here's a good one.
Okay.
I like the what they did this. They highlighted it. They put the bars above it. It's fine. That's good. I like it. Another one that I saw that I liked. I was not expecting this one. I was expecting the other ones. This is still good. This is still a chord. Hopefully that will show up there. There you go.
AC?
Okay. Here's a chord that I just shared with you. Those are two different answers. They're both chords. Chords, by definition, the endpoints lie on the circle. You don't need to use the center dot. You don't have to anyway. But AC is a good one. BD is a good one.
What
Those
do
are
you mean
good.
by we don't have to? Like, could we?
No.
Just say we
No.
don't.
I'm just saying that it doesn't always have to pass through the middle to be a chord.
Oh, okay.
Because that would be a nightmare. But yeah, so a bunch of different examples here. Now, if we had extra lines on this one, like if there was a line drawing from A to B or C to D, those would be chords. But they don't have those filled in, so you don't want to use those still.
What would be ones like that one?
Eventually, like the last sections, because we learned formulas and like when you have chords that cross and they have lines, there's like relationships to all the lines that are on that picture. Because chords can only be a certain size, like there's a max and a min to them before they're too small, or too big. So there's like a weird relationship between all chords. Like you can get from one chord to the other by using certain numbers. All right. Next example. This is a keyword that certain picture on here. The pictures I'm going to put on the board are different, so you might want to draw like multiple pictures here.
May I have attention please? Jamie from Athletico is now ready for any juniors or seniors that need to see her.
Okay. So one of the definitions here that we're going to be looking at is coplanar circles that have the same center. Okay. Now the keyword here, as you can see from your nearpod, the keyword there is that it's still based on circles. You know, they're still a circular path. They're coplanar. They're on the same flat surface. That's the word coplanar. But they have the same center. So now, if you look at the board, I'm going to have a different picture than you. Okay. So my picture. These are coplanar circles. They're on the same flat plane. They're on my marker board. They have the same center. So my picture, they have center A. Now, I think the example I have on yours, I think I have a target from archery, correct?
Yes.
An archery target. There's a bunch of different examples. That's probably the most iconic that most people are probably comfortable with, since a lot of you are in Broken Arrow's archery club. But this one is probably the one that I'd probably use the most in geometry, because I remember very vividly in doing the ACT when I was in high school, where one of the questions for me was find the area of this shaded path.
Oh my god, that seems hard.
And it's not. Because the area formula for a circle is very simple. It's like a quick calculation. So all you have to do is find the area of the big circle, and then subtract the area of the small circle in the middle, and that would give you your answer. It was just like this simple calculation. It took about a minute to do it. By just typing in your calculator, if you had a nice calculator, you could do it really quick. But again, what's important here is that the circles, what makes them concentric, they have the same center, and the other thing that I didn't have listed here, they have different radii. Like this radius is different than A to B. So you can see like the circles are different sizes, but they still have the same center. And then the radius that I have my little arrows pointed towards, that's how you find area. You have to use that stick to help you find it. So it's pretty easy. If you have that number, it's an instant calculation to find area. But I just remember that problem very vividly. Now, if it was three-dimensional, or they're rounded off, that would be a torus. I know a lot of the shapes in space would mimic a torus. You know, there's some planetary bodies that are in the universe where the actual planet itself is a torus in shape. It's hollow in the center because it was expanding. I just thought that was kind of an interesting concept. But the concentric circles here,
Yeah, I know.
but let me show you the example here. So here's the word that is obviously on your nearpod. That's the word concentric circles. They have the same center. But the other examples that I had that I was thinking of, like, what are like iconic images that are concentric circles other than, you know, the target that you're seeing on your nearpod? This is one that I just thought of the other night. Like the target symbol, like the shopping center target. Like they're concentric circles. Yeah, they're concentric circles. They're circles inside of other circles. You have a same center. You have multiple different radii. So you can either use the white circle, the red circle, but those are easy things to calculate. Okay? Question?
What about Saturn's rings?
Saturn's rings, yeah, those are concentric. The idea is that they're probably, I know there's some that are very, very rigid, but there's a lot of like floating rock and ice debris in there. But the idea is that, yeah, they're perfect examples of concentric. I think almost every major planet outside of Jupiter, I think even Jupiter has a small one. They all have rings around them. Jupiter has a small one. You can hardly barely see it. Saturn definitely does. Uranus does. And then Neptune.
Uranus?
Yeah, that's the correct pronunciation of it.
Yeah.
What?
It is. It's actually.
Right.
My life's a lie now.
And then Neptune does have a small ring around it as well.
Travis, you're right.
But-
You learn more in this class than
I
any
learned
other.
more in this class than any other class.
Yeah, that's
But-
so true.
But they're all concentric circles. Even our own even our own little galaxy right here, our own little solar system. There's rock belts like the Kuiper belt, and there's other belts around the outside that mimic concentric circles because there's floating rock debris.
You should
in
have
those?
became an astronaut.
I took a lot of science
Or
classes.
could have gone to
So
space.
I applied to be an astronaut.
You did
I
not.
did.
You're
Yeah.
crazy.
So.
Or it could have been a man on the moon.
NASA didn't even like acknowledge, didn't even send me a rejection letter. They just said my account was expiring, so I think that is a hard rejection.
Are you kidding
So,
me?
yeah.
Wait, what
Strapping
do you
young
have to
lad
do
like
to,
you.
like,
Send them an email right now and say,
What
I
do you
still
have
want
They had
to
an open policy for any math teachers to
Oh,
submit to be an astronaut, because they want to put math teachers in space to do like a time program with some school systems. And I was like, yeah, I'm doing that. 18,000 people applied.
No, I said two.
Yeah, I was hard rejected.
How many
Whatever,
people
you're the
did
best
they
one.
accept? One?
They
Well,
accepted
you'd be a
eight.
great
Instead of
astronaut.
18,000. It
Number
was like,
one out of
my chances were better
18,000
winning the
right here.
lottery
Yeah.
than getting
Come
that.
on, we're
So-
emailing NASA right now.
Nah. So, alright. Concentric circles, here's the example that I gave you here. This is kind of the most iconic image that probably you guys see. But anyways, let's get to our new formula. So one of the words that I want to talk about here is the relationship between a diameter and a radius. Right? There is a weird relationship there, and I want to discuss it. So here's the picture that I have shown. I even have the label, the diameter and the radius labeled in there. There is a relationship between a diameter and a radius, and I was saying this earlier that to make a diameter, you basically just take two radii and put them in a straight line, which they call collinear. They're just in a straight line with each other. So one of the formulas that I have here is if you need to find a radius, you take whatever the diameter you have, like to say you have the length of the diameter, and you divide it by 2. Because that's simple, right? So let's say the diameter on this picture, let's say it was 14 inches. Let's say it's 14 inches. Well, you divide it by 2, and that would be 7 inches for the radius. That's the easy calculation for it. Or, going to the other one, if I gave you the radius, you could find the diameter. And they could be decimals, right? So don't feel like they always have to be whole numbers. I mean, this could be 4.2 inches. And then I want to go find the diameter. So I take 4.2 times 2, and I get 8.4 inches. So that would be the rate, or the diameter I need. So if you actually multiply it. Easy calculations. Because I said, the radius is the most important number. If you have the radius, you can find diameter, circumference, area, arc length. You can find a lot of different things.
Did those math teachers go to the moon?
They're still in training. They had to train for 6 months down in Houston.
Wait,
And
when
then
did
they're-
you apply for it?
3 years ago. 3 years. 3
What
years.
if you got like an email tomorrow and like, hey,
Nah, they
good job.
already,
Sorry,
they
one of the
already
guys
announced
died.
who the select teachers were. They were looking for people between
Was it
25 and
from Iowa?
35. So it was
Well,
like,
what if you're a film?
no. So I had a good chance just because I went to Iowa State and they have a NASA program at Iowa State. So I had a good tie-in, so I was hoping I want to at least be like
What
in
if
the
they
top.
call you up, be like, yeah, one of the guys died, we need you.
No, but then I also found out, here's the crazy thing. I found out because I applied because I thought it was awesome, and I wanted to go to space, but the second thing I figured out is that those applicants were also thrown in the hat to go to the Mars program. And I didn't know that, because the Mars program is a graveyard program.
Yeah.
You don't come back. And I found that out after I hit submit.
That would have been
I'm like,
worth it though. I would have wanted to go to the moon.
Guys, imagine if Lord was imagine if Lord was gonna go to Mars and never come back. We'd throw you a wild party.
Alright. Okay, inappropriate. Alright, moving on. Inappropriate. Alright, here we go.
It's a birthday party, right?
It's a you're gonna die on Mars party.
So, yeah, I found that after I hit submit. I was like, what? That wasn't in the fine print.
Get
Alright.
there.
Alright, distance around a circle. That is called circumference. Now, here's what I didn't have on the slide, and I wish I would have added this. We've had a word for going around an object before, like the distance around an object. It was called perimeter. We only use the word perimeter if it's a polygon.
Perimeter.
Okay? Polygon is something that has straight edges, right? Straight segments connected. A circle obviously has curved paths. It's a conic section, if you will, to part of a cone. But the idea is that perimeter we use for polygons, circumference we use for circles. So they had to come up with a new word because they're not using the same object. Circumference going around. So I have a nice labeled picture. You can see it on yours. There's an easy calculation to find circumference, but a lot of people don't understand like why it's important. Like what's the whole point of that? Let me give you an example. This is the formula, by the way, for how you calculate circumference, the distance around an object. So you take 2, you take that times pi. Pi is this symbol. It kind of looks like a paragraph symbol in English. Pi is on the board there, 3.14, and then you take it times the radius. That's what you do. So that's tells you the distance around an object. So one of the objects I was kind of thinking of was a girl's basketball, right? To figure out, I have one. So
Magician.
yeah. So the idea is that to find the circumference, the distance around, so it'd be like this little black line going all the way around the object. If I had the radius of this circle, you can calculate. Now this one's a little flat. It's actually really flat. But the idea is that it's still kind of holding form. So okay. I don't want to throw it because I don't want to damage the computer. So it's really flat. Yeah. But the idea is that we can calculate the circumference. Yeah, it doesn't bounce. All right. So. Erica, here's what I need you to do. In inches, I want you to measure the radius. So just put it on the circle itself, and then measure, and just kind of eyeball what the radius of that circle is. Yep, just like that. Roughly, just ballpark. 5?
28.5.
So, let's say it's 5 inches. So that's my radius going from here to the outside. So this is the radius, is 5 inches. So if we're going to calculate the circumference of your actual circle, okay, you take 5 inches, you take that times pi, which is 3.14, and I don't need to go any more decimal places than that.
15926.
Yeah, and then I take it times 2. Well, if you do this correctly, take 2 times 5, you take it times 3.14, I get 31.4 inches on a calculator.
Oh, we were wrong.
Yep.
Just a little bit.
And, yeah, and the idea is that that's my circumference. So, what that means, can I see this? Back, yep.
Is there any way to get a whole numbers without a decimal?
Were you gonna
Yeah.
throw the ruler?
I'll check on that.
It's possible. I don't want to do it.
No,
Okay. Alright, here's the idea.
I mean,
This was 5 inches, but what this is saying that the circumference, if I had a cloth tape measure, which I don't, it's saying that the circumference of this basketball is 31 inches around. That means that's more than a foot. It's more than 2 feet. It's almost 2.5 feet around. That doesn't look like it's 2.5 feet around. It's deceiving. It's a circular path. So let me just show you this. So I'm going to start right here at the top. And I'm just going to wrap my tape measure or my ruler around the object. So I'm not even halfway around. Not even halfway around. And I'm to here. Spin around, keep going. And keep traveling the path. And yeah, I'm not even there yet. And then I still have to go a couple more inches to get to halfway, which is actually, you're almost dead on. So it's almost 30 inches exactly. Okay? So, not bad. Now, why this is important, calculating circumference. It's deceiving. It looks a lot smaller than it is. It's almost 2.5 feet around. But this, I want to give you an example of what would apply to you guys. Let's say this represents your car tire, okay, on your car, okay? If your car tire is flat, which this one is most definitely flat, you're actually going slower than your speedometer says. Because your car doesn't know the size of the tire. It's programmed to know what it should be. Okay, that's what the computer is programmed, right? So when your car tire is flat, because like over the winter you lose air pressure, you're actually going slower than you think you are. So that's why there's sensors on the car that tell you if you have maximum air pressure or if you need to fill your car tires with air. It's a little Bluetooth sensor on the inside of the tire. But if it's overinflated, yeah, it's Bluetooth. Yep.
Your wheels?
Yeah, the tires actually have a Bluetooth sensor in it. That's how they can track cars and stuff.
So you can be
on the
like-
highway. So.
Like click the button inside the car, like the Bluetooth button. Like the button that you click and then you say like call.
No.
What if you play music out of your tires?
No. So it doesn't have a speaker. So all right. Hey, we'll continue with this topic tomorrow. I'm gonna continue.
Kevin, I know what you're saying. Makes sense.
learned that
Because you're
word
a
on the
real
switch.
person.
The moon?
Space.
You guys didn't know that I wanted?
Dude, I'm gonna apply for you.
Yeah, I was really jacked because they were just looking for a math teacher that could do the projects in space with schools, and I was like, this is right up my alley. This is what I want to do.
We're getting you in.
It's not gonna happen.
Hey, Ward, you have those tests ready yet?
No, are you kidding?
Well, you'd be wrong.